what I'd like things to be. Just say, my name's Dave. I'm the zone coordinator for the whole of South Wales region. So my area covers right the way up beyond Powys and right the way across into Carmarthen and Pembrokeshire and all around there. I cover about 9 different teams in Wales. But in Cardiff, we've been building this mesh network, which I'm just hoping everything's going to work now, straight out of the box, because I wasn't meant to be doing this, sort of meant to be doing the next one. So I'm just hoping everything's ready. Let's just make sure this works first. Yeah, there we go. Okay, so anyway, we have been building a mesh network in the Cardiff area. It's still, although it's been going since 2016, it is still very much a very basic project. And I'm just going to give you a bit of an introduction. This is something that I delivered to our RAINET team. It hasn't gone anywhere beyond that at the moment. And one thing, I never ever say that I'm well versed in what I'm doing. All right, I know there are many, many people out there who have got much more knowledge on this sort of thing. I've got into this because I had what we would class as an architect, somebody that could build the network and put it all together for us. Make a start on it, and then pretty soon after he'd made this start on it, decided that he'd become invisible. And any time I tried calling him or whatever I tried to do to get hold of this person to develop it any further, I was hitting my head against a brick wall. So I had to step in myself and try and learn as I'm going along. And like I said, I'm no expert. You guys will probably jump all over me in relation to microwaves and things like that. But I'm just going to give you a basic introduction to the mesh system that we've got, what the concept is, and sort of give you a bit of a picture on our desire on to build a sustainable, resilient network. This was, as I say, this was for our RAINET group. So the third point I've got there says is offer opportunity for others to get involved, skills permitting. And that was aimed at any members of our team, which there's not a very high skill base in this particular line. But again, if there's anybody from this area who's interested in getting involved after I've done this, by all means come and speak to me, because I'm desperate to get this thing well off the ground. And also it was allowing for ideas on potential funding. Again, this is outside of this group, and prospective strategic site identification, because one of the things we have been struggling with is to try and actually get locations where we can put this equipment in to actually make the network a successful network. So the aim here is just to deliver a basic understanding of mesh, its concepts and its benefits. I'm sure most of you probably know about it, what mesh is all about, but we formed this little group called Mesh Cymru. And it's a collaboration of local authority. It says local authority, but it's actually now local authorities, because Cardiff Council and the Vale Glamorgan Council are both on board with this. And in partnership with us in RAINET, we're looking to build this network that will initially bring these two councils together with some resilient equipment that, should something go wrong with everyday communications, we should be able to step in and provide a backup. It came off the back of a presentation from a group called FeedNet, or a network called FeedNet. Again, it was within RAINET, and I saw a presentation this myself in 2015, and it sort of blew me away at the time. And they tell me it's nothing new, it's been around for a long, long time, but it's only now that it's coming to the front. You're hearing about it in all sorts of places these days, people setting up mesh networks in buildings and everything else about it. But when I looked at this in 2015, it was very, very much something on the back burner. And they were producing this network up in Scotland, and it was across the Firth of Forth, where there's the Fastnet the nuclear power submarines and all sorts of things. They would fuel places at Grangemouth and everything. And Police Scotland said, we need something in place that, should something happen to the everyday communications, we need to be able to communicate across this area. So back and forth, the Firth of Forth, they put all this equipment in, built it all up, and they have a very successful network running from it. And like I say, I was amazed when I saw it. So in 2016, Mesh Cymru was born, and we got our first grant, which was from the lottery, to be able to deliver a basic infrastructure. In 2017, we got another smaller grant, which allowed us to add some stuff to this infrastructure. So what is a mesh? It's a mix of radio transmitters that's in fact no different to your home routers. When we started building this, I don't know, as you are sort of amateur radio based, some of you may or may not have heard of broadband hamnet. If you have, then initially we started using their firmware, and we were using Linksys routers, just something where somebody had finished using it in their house. There were particular versions that were very susceptible for us to be able to switch into this broadband hamnet software. That's not coronavirus, is it? Anyway, so from that then, we put a couple of these routers together, and we started building a very basic network that would work across just a room, and then we took it further, and these things worked quite a way away just for being a basic sort of home type router with a enabled amateur radio firmware on it. So they're modified with specific firmware to enable long distance use on amateur radio frequencies. We are now using some commercial equipment. We've moved away from the home routers, but you'll see that as we go further down the line. They're termed as nodes, and they create a mesh network with these nodes to interact with each other. So how does it work? These nodes, they form a network of interconnected transmitters. They need to be situated in strategic locations to be effective because, as you guys know, we're working around 2.4 gigahertz and it's line of sight pretty much. So there have to be some sort of strategic location that's able to see over long distances. They're more effective when they're placed in close proximity to each other, but they can achieve hops of between 10 to 20 miles, even 50 miles has been achieved depending on the terrain. In the States where they have a lot of flat land and things like that, I've read from some of the, there's like a Facebook group that is ongoing with the, it's called Arden, the actual firmware that they use, or the group that are dealing with this in the States. And they're getting phenomenal distances out of these things. Running on the amateur radio part of the 2.4 gigahertz networks, and 5.8 I think they're using as well, or 5, whatever it is, 5.8 I think. So the nodes must remain in direct line of sight to be effective. And so what do we require for the infrastructure? Obviously the first thing for us is a node location. It's got to be somewhere where we can site the equipment in the first place. Then a node radio transmitter. An antenna or antennas designed for the location, because there are various different antennas out there. Obviously, you can get the omnidirectional, you get directional ones, you can get horizontal and vertical polarized antennas. So depending what you want to set up, depends which type of antenna you select for the job. Then we need obviously the hardware to fix it to either poles or brackets on buildings or wherever we want to be able to get this node in position. Prominent location, as I say, it's got to be somewhere where it has got a good line of sight in the direction you want to go. Power supply then, either mains or battery. For us, our preferred option is battery or something like solar panels, wind power, various different things. I mean, I've got a wind generator that was purchased for it. It's still in a box in my house. It's been there for over 3 years because at the moment I haven't been able to find some way of putting it anywhere to be able to test it out. So what about resilience? The equipment, as I say, can run on battery power. Wind generators, solar panels, generator power is an acceptable norm for resilience, because obviously we're looking at a situation where something has taken out the fixed system that we have in place, your electricity supplies, or anything else that may well have brought things down. As you see, recently we've had storms and things like that. We've had, in parts of the country, they've had electrical substations underwater, which has taken out the power supplies and power services. So for us, these are the terms of power as something that will help us. And it's beneficial to the local authorities and emergency services, because if it's fixed to an off-grid resilient supply, then it becomes some key strategic equipment should everything go wrong. Strategic sites, they can have a combination of antennas each with a fixed node selected for its specific purpose. As I say, if you want something in just a small area, we would use an omnidirectional antenna. If we want to put something into a specific point, we would just use some kind of point-to-point panel antenna. Or if we want to do something on a strategic site, we would try and put something that will cover 360 degrees so that we can get the best out of the equipment, and then normally horizontal and vertical polarization. So that if we're picking up noise on one of the polarities, we can switch around and hopefully null out that noise. For us, they must have some form of security to prevent theft or tampering. And additional hardware required can be strong boxes to house the equipment, because our plan in relation to sighting mesh equipment is that we may well have an incident somewhere where there is absolutely no equipment in place, and we may be able to sort of find the link to our network, but it might be somewhere where it's completely out of the way and we've got to leave that equipment on site and head off somewhere else. So the last thing we want to do is put it somewhere where someone can just grab it, pick it up and run off with it. One of the biggest tips we got from the guys in FeedNet is plaster radioactivity stickers all over it, and nobody really wants to take away a box that they think is going to do them a lot of harm. But yeah, we would chain them up to trees, whatever else we could do if we need to use these things. So the concept of mesh. Mesh networks, they're an array of nodes that communicate with one another. The word node is a piece of jargon, but it basically means a connection point. And they're classed as either partial or full topology networks. In a true mesh topology, every node has a connection to every other node in the network, so that would then be termed as a full topology network. I'll show you some pictures of that or some demonstration diagrams of that in a second. It stands to reason that a partial topology network has nodes that don't have a connection to every other node in the network, hence the partial tagging that it gets. And it's more susceptible in a partial topology network to possibly break down at some stage. In a perfect mesh network, it would be a full topology network. That's an example of a partial topology network, each of those yellow dots representing a node. And as you can see from it, if they're placed so far apart, there's only sort of one connection between each of them, point-to-point sort of connection. So in the event that if you're trying to get something from here to here, and this breaks down here, you lose the network. So, you know, it's sort of, it's not very resilient. Whereas on a full topology network, if they're all within range of each other, if you do have that breakdown, then these things will pass the signals and bypass it automatically so that you continue to get your signal through to wherever you need to get it to. And again, then adding on the end of it, there's the partial topology. So where this is quite resilient, again, if you get a breakdown here, you're quite likely to be able to still get something through on the other side of things. So, you know, it does make it a little bit easier, but, you know, if we have a breakdown somewhere else in the network, it could well prevent that signal from getting through. And that's just an explanation there, because this was, as I say, pitched for the guys in my RayNet team that knew nothing about that, what a point-to-point link was and a point-to-multipoint link. And we're aiming for that point-to-multipoint link, which gives us that better topology on it. This is a bit of a situation. It says currently 11 nodes in 5 locations on our network. Since I've done this presentation some time ago, that key structure there at number 3 has disappeared, because we were in a situation where it was on a very sensitive site, and the site owners were having a lot of jitters around cybersecurity and Russian hackers and all the rest of the stuff. And as they got a bit jittery, they'd said, "Oh, we don't want this on site, can you take it off?" So we had to remove it all from the site. So at the moment, that network is not as it seems there. These other 4 locations still remain. There is some continuity between these 2. Number 2's got absolutely nothing at the moment because it's down in a dip in the middle of nowhere. And that one at number 1 there is my home. But what we're doing next week is I will be taking a trip over to Flatholm Island, because there's a very good line of sight from Flatholm Island. I'll be taking some kit over to do a demo, a bit of a test, and Flatholm Island will be somewhere down this way. So we're going to put that in place, which should link up these and mine. Again, we've still got to find a way to get that other location online. However, again, as I was saying earlier on, if we were to put ourselves in a position whereby we desperately needed to get something in there, we would take our mobile nodes up with our strong boxes, radioactive stickers, or whatever we want to do, and put them in some location that would give us access into that particular point. But on a day-to-day basis, that's currently offline, as is this at the moment, with a link up into Cardiff. But as I say, as soon as we've got something down Flatholm Island, which I'm more than positive, when we did some site tests and some checking, we found that there was line of sight and paths coming from Flatholm Island that you wouldn't get from anywhere else. And it was very, very good for a huge part of the area that we cover to be able to get a very stable network in place. So fingers crossed, after we've done that survey next week and we find a time to go over there and put something in place, we should get a more effective network back online. So beyond the infrastructure, well, what can it do? You know, it's okay to put a network in, but we need to find out exactly what we can do with that network. It will provide us with an email function, VoIP telephony, RoIP communications as well. VoIP telephony is in voice over internet and radio over internet. Just, I'm sure you knew what they were anyway, but just in case you didn't. Webcams we can integrate into the system, internet relay chat, and a file server for storage and sharing, because obviously in a situation whereby we have a main system go down that's unavailable under normal circumstances, we can store files which are important to both us and to the local authorities, so that we can still get hold of them and share them if the main internet goes down and there's a loss of service. So if we want to enhance our network, how can it be achieved? The additional infrastructure is the thing. The closer the proximity to each node it is, the better things go. The bandwidth is better. We're able to get more reliable communications. And I have seen, when I've sort of travelled in certain parts of Cardiff now, they're starting to put omnidirectional antennas on some of their lampposts with the lighting. Now, one of the things I haven't seen, because we don't get to play around with stuff like that, is no doubt with all the LED lights in there, they may well be chucking out all sorts of rubbish that would cause problems. But if we could get hold of quite a number of those lamp standards to fix equipment to and power it from within their systems, or add battery packs in the bottom, then we could get that closer proximity that we're looking for and a more reliable network, because the more we can get in, the better we can provide them with a service and the further we can take it. We would use, as I said earlier on, some mobile nodes in filling incident locations, because we don't know where something's going to pop up. Something could crop up anywhere, so we may have a terror incident that might just appear anywhere within the Cardiff or Vale Glamorgan area. And our job would be to try and get something into that area and get it linked into that network, so that we can start passing information back and forth to the control rooms, because the local authorities will be involved in the recovery, trying to get everything back to normal, and they would also want some information in real time as to what's going on, where we could take photographs, send them back through that system, or connect up a webcam and give them what they need. As they say, a picture's better than 1,000 words, so you should be able to show them exactly what they're dealing with on the ground. We do this again by using these standalone portable nodes as well as mobile, because I can just chuck the mobile node in my car, go somewhere, park it up, point it somewhere, and hopefully get back to it. And these standalone in places like I showed you earlier on, just outside of our number 2 point, which is lost all communication. We just find a high point somewhere, pop something on there, a couple of antennas pointing in the right direction, and fingers crossed we would get something into that control room. One of the things for us is achieving it is secured continuous funding, which is a very difficult thing. And you'll know in most sort of volunteer things, try and get money is just near impossible. But for us, it's the way to actually develop this thing to where we would like it to be. And this strategic site identification and getting permission to use these sites is another thing. I mean, there's a lot of high buildings in around Cardiff city centre. Whilst they would be great if we can get something on there, whilst we can't, it's very difficult to get things around them. And with the Cardiff control room smack bang in City Hall, in the centre of Cardiff, I mean, we look at certain buildings like the Capitol building. There's about 14, 15 stories high, maybe more. with a lot of other big buildings around it. And then you can see how easy it is to lose your signal when you need a line of sight. So, you know, the more permissions we can get to use high-rise buildings around the area, the more chance we got to throw in this signal right around the city and beyond. And this resilient power source on all available nodes, because if everything's resilient to power, then we should be in a situation whereby nothing is going to deter us in the event of a full-blown emergency. Beyond the infrastructure, this is peripheral equipment that's required, the flesh on the bones, as we call it. And this is in this presentation as well, because I do try to speak to people outside of the RAINET groups, or this was designed in that way so that we could look at speaking to people who may have some second-hand equipment that we could get our hands on, because we do need computers, IP phones, webcams, smartphones, printers, radios, network switches, and standard routers, or ideally dedicated access points. I mean, the standard routers bit, we wouldn't use them for nodes, but we would use them for setting up a small Wi-Fi network, say in this room and another room, where, for example, we want to pass data. I think I might have an example on the next slide, so I don't particularly, I'll speak about that in a second. But the benefits of this is independent of our global network of internet that we've got out there, because we, as I say, we're setting our system up for when everything else fails. And whilst we're going to be able to put local authorities and fire, police, ambulance on this network, what we're not going to be able to do is put 200 computers, 300 computers on it. It would basically be a single terminal in each of the emergency services, so at least they have some form of communication rather than no communication. Because I don't know how much you know about the emergency services and their network. They're currently on a Tetra network, which their contract has already, I believe, now run out. And they're still holding on to it, but they're looking at this new 5G system where they say they're going to be able to communicate right across the UK. We have our doubts whether that will be anything that's going to be anywhere near as reliable as they think. So, right, okay, so the benefits of our mesh network is that we want it to be independent of the global network, but it can be patched to that global network, but we don't want to do that. We don't intend to do that because, again, if governments are brought down by some cyber hackers, the last thing we want to do is to be able to allow them into our network. If we keep ours independent of the internet, there's no way that they can put us anything onto our equipment and sort of hijack it. Again, the benefits is being available off-grid with resilient power provided. It's a private network, so it's less likely to be a target of cybercrime, which I was just saying. And it can be deployed mobile at a moment's notice into an area, providing there's line of sight to a strategic node somewhere within the system. Several mobile nodes can be deployed in an area to provide site-specific needs. This is what I was saying just a moment ago. So without actually connecting to our main network, we could put a couple of mobile nodes together in a small area, say a rest center, or if we're at a checkpoint for a marathon or something like that, where we've got 200, 300, 400 participants, and we can check off their numbers into a database and be able to check that everybody's passed through and that we can close stations down and move on to the next point. So it's a benefit to us if we can just set up a small network without having to rely on our main communications network, unless we require it to go back to an event control which is run by the local authority. So these are some examples. Our Lambie Way node. That one there is, there's two antennas on there. They are directional and they cover 120 degrees each. So we've got 240 degree cover there. Both of them pointing inland from Lambie Way landfill site, because obviously the third node would be out into the Bristol Channel, which we don't have any boats with mobile nodes on, although, you know, it would reach beyond into the West Country. Our concern is obviously for Wales and for this area, so hence the reason why we've got two nodes on that one. The one on this side takes into City Hall, and that one goes right up into Risca and into Newport, so it will take us into another local authority area should we wish to do something with that. This is just one of our mobile testing nodes, just something shot in the boot of a car, powered up off a 12-volt socket, and then up to a node. And that was working from St Hilary, which is down in Cowbridge, and that was getting a decent signal when we had our strategic point in Wenvo. No problem at all. We were able to pass quite a lot of data speed through that. Then there's a full look at the tower there at Lambie Way. So it's up about 8 to 10 meters. We couldn't get to the top of the pole because their cherry picker wouldn't go any higher than that, because I would have left it gone on the top, because I bet we would double the distance on it. Although if you look from the 10-meter pole or the 10-meter height across, it's got a fantastic footprint right into the South Wales valleys and right up, as I say, through Risca into Gwent. This is just an omnidirectional. That's in my back garden. And that has perfect line of sight into Flatholm Island, which is sort of just around this way off the coast. Some more examples. Not sure, that picture's not very clear because it was, as you can see, not a very nice day. But there's an omnidirectional antenna with a small panel that was pointing over to Wenvo, our strategic site, and it's powered off a small box that we have set at the base of it. That one is mains powered at the moment, but I have every intention in the future of making that resilient and putting it on 24 volt so that we can power up the nodes off it and leave it independently. I think that is the end of the presentation in relation to what we do. I don't know if you have any questions and whether or not I can answer them, but I'm more than willing to give it a go.